Here's an authorization puzzle that trips up a lot of systems. Sometimes the thing you're changing isn't the thing you check permission against. Can this user edit this order? Well, it depends on the customer the order belongs to. Can they upload this matches scorecard? Depends on the teams playing in it. The resource you touch is one hop away from the resource that actually owns the decision. And in a distributed system, that owning resource might live in a completely different service. Let's untangle it. Let's name the problem. The resource you're acting on, call it the leaf, is often not the resource that owns the authorization decision. Uploading a scorecard mutates a match, but who's allowed to do it depends on the teams. Editing a line item mutates the item, but ownership lives on the order or the customer above it. The thing you can authorize against is one or several. Navigation hops away from the thing you're touching. And if you only check the leaf, you've asked the wrong question about the right object, which is a subtle, dangerous bug. The clean way to model this is to make the navigation explicit. First, you identify the leaf you're mutating, and the pipeline loads it for you. No manual fetch. Second, you declare the path. This resource points at those related owners. A match points at its two teams. The framework follows that declaration and loads the owners. And third, you write your authorization rule against the loaded owners, not the leaf. Crucially, the framework hands you the owners as a list and stays out of your way. Your rule decides whether the actor needs to own any one of them, or all of them, or something else entirely. The navigation is declarative. The decision is yours. Here it is, the framework's own example. Uploading a scorecard is a command that mutates a match, but you don't check ownership against the match. You check it against the teams playing. So the match declares its related resources, the home and away team IDs. And the command says two things. Authorize me via the related team and identify the leaf I'm actually mutating, the match. The pipeline loads those teams and hands them to Authorize as a list. And the check is simple. The actor must own at least one of them. Any home or away owner can upload the scorecard. This scales in two directions. It fans out. A match points at both its teams, so the owner list has two entries and your rule can accept either. And it chains. A match points at a team, which points at a tournament. Declare each hop, and you can authorize all the way at the end of the chain. One rule the framework enforces for safety. A command uses either the direct check, authorize against the leaf itself, or the via check, authorize against a related owner. Never both. Security primitives don't get silently composed. You say exactly which one you mean. Now the distributed catch, and it's the whole reason this episode belongs in a microservices series. To authorize via a related resource, the framework has to load that resource, and it expects to do that cheaply in process. But what if the owner lives in a different service? The tempting move is to call across to that service during authorization. Don't. A synchronous cross-service call on every auth check is slow, and it couples your service's availability to another's. Now they fail together. The right answer: keep a small, local read model of just the data you need to authorize against, kept in sync by events, which is exactly what we build next. Authorization stays in process and fast. The data comes to you. So, authorizing across hops. The resource you touch often isn't the one that owns the decision. So identify the leaf, declare the navigation to the related owner, and write your rule against that owner, choosing any, all, or your own shape. It fans out, and it chains. But the deepest lesson is the last one. In a distributed system, you never reach synchronously into another service to authorize. You keep a local read model and answer from it. Which leaves exactly one question hanging. How does that read model stay current, reliably, as data changes in the service that owns it? That is the next 2 episodes, events, done right. Subscribe, and I'll see you there.